All right, so question number 3. We're shooting a metal sphere with a slingshot, looking at its height at various different angles. So the relationship being studied is how does max height depend on angle? The independent variable, the variable that we have total control over, is the angle. And I'd say we should measure that in degrees. And the dependent variable, the one that we don't know but we're trying to find out, that's going to be height. And if you wanted to say feet or meters, that'll be okay for the test if that comes up. Now, what variables must be held constant throughout the experiment? Let's see. I'd say the weight of the ball. We're shooting it from a slingshot, right? So the tension in the slingshot, I guess, whatever you want to call that. Those are just a couple of examples. I'd say the wind, right? So those are just examples of control variables. So that's good for number 3. It's a great way to get us started. We're not doing anything beyond that in this problem, so that's great. Now, here it says write a mathematical model that describes the graph. Now it says 1E03. I just want to be clear. 1E03, that's another way of saying 1,000, just so you know. Now it says write a mathematical model, and this is set up very, very nicely. So I can actually say scholarships, that'll be my Y variable, and effort will be number of applications. So I'll say scholarships equals 500E, and my intercept is 0. And the interpretation of the y-intercept basically says 0 apps means no scholarships. If you don't get any effort, you don't get any scholarships. So I guess that's a metaphor for something, seniors. Oh, okay, hilarious. Now, how many applications would we need to earn $8,000? Well, that means for S to equal $8,000, we'd say 8,000 equals 500E. And we can cancel this out. And when we simplify, we're going to get E equals 16 applications. So that answers question number 4. So we've done 3 and 4. And I'll take a look at the next page in the next video.